Welcome to the final part of MB3. Myself, Gokul. I'm working as an assistant professor in the Department of Master of Business Administration in Srinathkumar Institute of Technology. Subject code is MB25202 and the subject is Business Analytics Regulations 2025. In this part 5 of Unit 3, Descriptive Analytics Visualization, we will move from describing data, understanding how we can use samples to make sense about populations. In this session, we will cover sampling and sampling error, population versus sample, and estimation, point estimates, and interval estimates, and the introduction to probability concepts. Let's begin with the sampling. Sampling is the selection of subset, a statistical sample from within a statistical population to estimate characteristics of a whole population. Why sampling? Because studying an entire population is so expensive, too time consuming, impractical, or impossible. A good sample should be representative of the population, meaning it reflects the population's characteristics accurately. Sampling error. Sampling error is the difference between a sample statistics and the corresponding population parameter. For example, if the true population mean is 50 and your sampling mean is 48 means the sampling error is 2. In every sample, there will be an error. We have to remove that error. After that, only we have to do some analysis. Sampling error occurs because the sample is only a part of the population. It's not a complete census. It's not a mistake. It's an expected part of sampling. The goal is to minimize sampling error with proper sampling techniques and adequate sampling size. The population. A population consists of all items of interest for a particular decision investigation. It's the complete set we want to understand. Sample is a subset of the population selected to represent it. Example, if we want to know the average height of all students in a university, will be considered as the population. We might measure 100 students in the university, means it might be taken as the sample. Understanding this distinction is fundamental to statistics. Then estimation. When a researcher makes inference about a population based on sample data, this process is called estimation. There are two types of estimation. Statistical reference divided into two types. One is estimation and another one is hypothesis testing. Estimation is divided into two types. One is point estimation and another one is interval estimate, which means interval. Confidence intervals. Point estimate is a single value estimate of the population parameter. Example, sample mean is a point estimate of population mean. Then interval estimate, a range of values where the population parameter is expected to lie. Example, we are 95% confident that the population mean is between 45 and 55. A confidence interval is the most common type of interval estimate. The interval estimate acknowledge the uncertainty inherent in sampling. You can see the estimate and estimator. Estimator, which includes the numbers, best guess of parameter, realization of random variable, where the estimator it includes functions, rule to make guesses, and the random variable. And this is the width of the confidence interval of the point estimates. Left side is considered as the lower confidence limit, and right side is the upper confidence. I've explained this in previous slides. Then probability. Probability is the likelihood that an outcome, such as whether a new product will be profitable or not, or whether a project will be completed within 15 weeks occurs. Probabilities are expressed as values between 0 and 1, although many people convert them to percentages. The key points of the probabilities are as follows. So an experiment is a process that results in an outcome. Second, the outcome of an experiment is a result that we observe. Then third, the collection of all possible outcomes of an experiment is called sample space. And fourth, an event is a collection of one or more outcomes from a sample space. The probability associated with any outcome must be between 0 and 1, or the sum of probabilities over all possible outcomes must be 1, comma 0. The union of two events contains all outcomes that belong to either of the two events. The two events are mutually exclusive if they have no outcome in common. The probability of the intersection of two events is called joint probability. The probability of an event, irrespective of the outcome of the other joint event, is called a marginal probability. Conditional probability is the probability of occurrence of one event A, given that another event B is known to be true or has already occurred. Two events A and B are independent if probability A divided by PV equal to probability A. A random variable is a numerical description of the outcome of an experiment. It may be discrete or continuous. A discrete random variable is one for which the number of possible outcomes can be counted. A continuous random variable has outcome over one or more continuous intervals of real numbers. A probability distribution is the characterization of the possible values that a random variable may assume along with probability of assuming these values. A probability distribution can be either discrete or continuous depending on the nature of the random variable it models. Then theorems of probability. Probability theory forms the mathematical foundation for statistical inference. Key concepts includes probability distribution, Bayes theorem, law of large numbers, central limit theorem. These theorems explains how sample statistics behave and how we can make reliable inferences. Then probability distribution. A probability distribution describes how probabilities are distributed over the values of a random variable. Common distribution include normal distribution, it's a bell-shaped and symmetric. Then binomial distribution for yes or no outcomes. Then Poisson distribution for rare events. Discrete distribution have finite number of different possible outcomes, where in case of continuous distribution, it have infinite many consecutive possible values. Understanding distribution helps us makes real world phenomena and make predictions. And that brings us to the end of the unit 3, descriptive analytics and visualization across 5 parts. We have covered introduction to descriptive analytics, what is and why it matters. Then charts and visualization, 14 types of charts and when to use them we have seen. Then data manipulation, sorting, filtering, and Pareto analysis. Then summarizing data, part tables, pivot tables, cross tabulation we have seen. Then statistical measure, central tendency, dispersion, and shade. And sampling and estimation from samples to population we have seen. Now you have a solid foundation in understanding and describing data, essential first step in any analytics projects. In Unit 4, we will move to the predictive analytics, where we will learn to forecast future outcomes. Until then, practice these concepts with clear data. If you found this series helpful, please like, share, and subscribe. Leave your questions in the comment. Thank you for being with me. Thank you. See you all in the next video.